All right, story number one, consider the graph of y equals the square root of x. Now to graph any equation, if you don't know what the graph looks like, this is the for sure method for graphing any equation. All right, now I'm choosing these 5 values for x. You're not limited to these 5 values, but these are a good set of values to start with. All right, if you plug -2 into the square root of x, you can't take the square root of a negative number. So these don't exist here, these points. All right, but I'm going to start off with 0. Square root of 0 is 0. And then plug in 1 into the square root of x, and you get square root of 1, which is 1. And then plug in 2, and you get the square root of 2. Or if I plug in 3, I get the square root of 3. If I plug in 4, I get the square root of 4, which is 2. So then I get a whole number. All right, and then you want to think about what other numbers can you plug in. So you get a whole number back. That would be 9. The square root of 9 is 3. All right, so if I plug in 0 for x, I have 0 for y. If I plug in 1 for x, I get 1 for y. If I plug in 4 for x, I get 2 for y. And if you plug in 9 for x, you get 3 for y. All right, so your graph looks something like this. Okay, that's the square root of x. Now, if I take this equation here, I'm going to translate it 5 units to the left and 7 units up. Okay. Well, what's my equation going to look like then? Well, here's the general equation. Y is equal to the square root of x minus h plus k. All right. So h is your movement left and right. So in this case, I moved back 5. So I'm going to have y is equal to x minus h in this case is -5. And then plus k. What's k? I moved up 7 units, so it's going to be plus 7. Simplifying this, I get square root of x plus 5. Keep that in the square root there. Plus 7. All right, so there's our resulting equation. All right, let me show you how to go backwards here. If this was given to you and they asked you to graph it, what would you do? Well, you look at the value inside the square root here, and you take the opposite of it. All right, so if you take the opposite, then you move back 5 units from the origin. All right, so just saying you start here, you move back 5 units from the origin, and then it says add 7 on the outside. So that means you're moving vertically, so you're going to go up 7. All right, so the key idea is you do the opposite of this sign here, and you stick with this sign here. All right, on to the next problem. All right, and the graph of y equals x squared is translated 3 units to the right and 7 units down. The resulting equation is y equals x squared plus bx plus c. What is the value of b? Okay, first thing we have to do is graph the equation. All right, once again, if you don't know how to graph a parabola, here are the first 3 points to start with. All right, if you plug those values of x in, you get those values for y. All right, so there's our parabola to start with. But the parabola is moved 3 units to the right. Okay, and 7 units down. Okay, here's the equation for a parabola in vertex form. Okay, so what's going on here? All right, what is my h in this case? H is your movement horizontally, so I moved 3 units to the right, so it's going to be minus 3 squared. And then plus k, I moved 7 units down, so that's -7. All right, if I simplify this, I get, all right, but that's not going to help us answer the question here. All right, I need to get my equation to be in this structure here, in standard form. So what I'm going to have to do is, I'm going to have to expand this and FOIL it. All right, do the FOILing business. So you get x squared minus 6x plus 9. All right, and then I have -7. So I have x squared minus 6x plus 2. All right, so what is my b value in this case? My b value is -6. Done. On to the next. All right, here we have a system of equations. And here I already have y isolated, so I'm going to take x squared plus 2 and plug that in here into the other equation. So 3x plus x squared plus 2 equals 2. All right, and I'm going to subtract 2. So I end up with 3x plus x squared plus 0. These cancel out, equals 0. All right, and then simplifying all this, putting it in standard form, I get x squared plus 3x equals 0. And then I'm going to factor out the x, so I end up with x times x plus 3 equals 0. And now I can solve this equation. X is equal to 0, and x plus 3 is equal to 0. So I subtract 3, x is equal to -3. All right, I got the two values for x. Now all I have to do is plug x back into either equation. So I'm going to have y is equal to 0 squared plus 2. So y is equal to 2. And y is equal to -3 squared plus 2. So y is equal to 9 plus 2. Y is equal to 11. So I have 2 points for this problem. I have 0, 2. And -3, 11. These are my two solutions for this problem. Done. On to the next. All right, first thing we want to do here is put this in standard form. So I'm going to subtract 3w over. So I have w squared minus 3w minus 70 is less than or equal to 0. Okay, before we even consider what to do with the inequality, let's just factor this expression here, this quadratic. So what two numbers add up to -3 but multiply to give you -70? 7 and -10. So you're going to have w plus 7 and then w minus 10. And this is less than or equal to 0. All right, so essentially you want to once again approach this as a normal equation. Just imagine that's equal to 0. So you want to find your zeros for the equation. So w plus 7 is equal to 0 and w minus 10 is equal to 0. So w is equal to -7, then w is equal to 10. All right, draw a horizontal line. Here you have your x values, or in this case it's w. Same deal though. All right, and then you want to test values to the left of -7, between -7 and 10, and to the right of 10. All right, so let's choose -8. Let's choose 0 here. Now let's choose 11 here. And all you're concerned about is if when you plug it in, either one, when you plug it in, do you get a positive or a negative value? Well, let's see what we end up with here. We end up with positive, and then if we plug 0 in here, we end up with a negative, and if we plug 11 in here, we end up with a positive. Okay, now I refer back to the inequality. It says less than or equal to 0. All right, so less than or equal to 0 means I'm looking for the negative territory, less than 0. So that's this territory here. All right, so I'm starting at -7, and I'm ending at 10. The variable I'm working with is w. All right, and then we're going to use two inequality signs to the left, to the left. All right, and this is a compound inequality to show our solution set is between two numbers, right? -7 and 10, and this is how we represent that solution. All right, if you have any questions, please make sure to ask about that. Moving on to the next. And just one last point, this is actually a parabola here. Oops. This is a parabola here, right? And we're concerned about what the x values, or in this case, what the w values are when the y values are negative. These are where the negative y values are. All right, on to the next problem. All right, in this problem, they give you this equation. They tell you r is the initial velocity, and here's the initial velocity. And they want you to find the maximum height the arrow will reach and at what time. And then also, when will the arrow hit the ground? All right, so first thing, let's plug this value in. We have h is equal to -16 t squared plus 128 t. Okay, well, I know this is an arrow I'm shooting up into the air. It's going to have a parabolic trajectory. All right, this is your maximum point. Or in other words, that's your vertex. All right, and your vertex, here's the formula for the x value. It's -b over 2a, okay, which is part of the quadratic equation. All right, so if I want to figure out -b over 2a, how do I do that? Well, here's your b value, all right, and that's your a value there. So what is -b over 2a? -b is 128, and I have 2 times a, -16. All right, so what do I end up with here? I end up with 4. All right, and in this case I used x, right? But you could replace t with x, right? They're essentially the same thing. We're just using different variables on these equations, but it's the same idea. You've been using x throughout algebra, but in this case here they're using t instead to represent time. All right, so now I have the x value, which is 4, and I take that value and I plug it in. And when I do, what do I get for h? I get 256. All right, and that's my maximum height. All right, but they also want me to find when will the arrow hit the ground. So the ground represents what value for y, or in this case h represents 0. All right, so I just set h equal to 0. All right, so now I'm going to factor out -16 and t, and I get t plus or minus 8. All right, so I set -16t equal to 0, and I set t minus 8 equal to 0. All right, so I divide by -16. T is equal to 0, and then I add 8, and I get t is equal to 8. All right, they want to know when the arrow hits the ground. Well, it's going to be in 8 seconds. 0 seconds is when you first shot the arrow. 8 seconds is when the arrow landed. All right, done with that. All right, if you need any clarification, make sure to ask for help. Okay, for this problem, how do you graph this equation? Well, let's add up the exponent values here. That's 4, so it's an even degree. And if it's an even degree, you get a U-shaped graph. All right, if it was an odd degree, you would get an S-shaped graph. All right, so starting off here, we have a positive value in front, so it's a normal U-shaped graph. It's not turned upside down. So we're going to start from the left here, coming down. And now what do? Well, I need to figure out where my zeros are. So I set x plus 4 equal to 0. So x is equal to negative 4. And x minus 2 equal to 0. So x is equal to 2. All right, so I'm going to go down and hit negative 4 first. Actually, let me redo that. Okay, I'm coming down. Let me erase this. Okay, here we go. All right, so going down here, and then I'm going to hit the negative 4. And because this exponent is even, that means it has even multiplicity. That means I bounce off of the x-axis then. All right, and then I'm going to come back up. And then it has to turn back around because it's going to have to hit positive 2. All right, so it's going to hit positive 2. And then what does it do there? Does it go through or does it bounce? Well, the exponent's even multiplicity, bounces off. So then it comes back up. All right, and that's generally a U-shaped graph. All right, so that's all we have there. We've graphed it. We're done. Moving on. All right, for number 13, we're going to do long division. So we have x squared minus 0x. Don't forget that. That's important. Then we have x to the 4th plus 8x cubed minus 10x squared minus 48x. All right, minus 17. All right, now long division is very easy. Just students make mistakes, you know, with placing certain values in the right place, or they forget to add or subtract. They miss a negative, so just be careful with every step of this process. So x squared times what gives you x to the 4th? That's going to be x squared. So we place it over here. And then I have x squared times x squared is x to the 4th. Negative 0x times x squared is just 0x cubed. And then I have negative 6 times x squared, so I have negative 6x squared. Okay. Now I have to change the signs for everything. Negative, negative, positive. All right, be careful with this here. Erase the signs if you have to. All right, so it cancels out. X to the 4th minus x to the 4th. Then I'm going to end up with 8x to the 3rd minus 4x squared minus 48x minus 17. Okay, that's my new polynomial to work with. So x squared times what gives you 8x to the 3rd? That's going to be positive 8x. So multiply now. I have 8x to the 3rd. Then I have 0x squared. Then I have negative 48x. All right. Change the signs now. Minus, minus, plus. All right. And so the first terms cancel out. Then I'm left with negative 4x squared. And negative 48x plus 48x, that's 0x now. Minus 17. There's my new polynomial. All right, so x squared times what is negative 4x squared? That's going to be negative 4. All right, so multiply, and I get negative 4x squared plus 0x plus 24. Now I have to change the signs of everything. All right, so this is going to be plus, This is going to be minus, and this is going to be minus. All right, so now I end up with what? Negative 41. All right, now my final answer is going to be x squared plus 8x minus 4 plus, well, what's my remainder? It's negative 41 over, what was my divisor? X squared minus 6. All right, simplifying that, I get x squared plus 8x minus 4 minus 41 over x squared minus 6. All right, that's your final answer. Okay, and on the answer key, they state the quotient along with the remainder. All right, moving on to the next problem. All right, if 4 is the root of this polynomial, find all the other roots. Okay, we could use synthetic division here. 4 is the root. I'm going to state all of the coefficients: 4, negative 8, negative 29, and negative 12. All right, bring down the 4, multiply, then add. Multiply, then add. Multiply, then add. Okay, so here are the coefficients to the remaining polynomial. So I have 4x squared plus 8x plus 3. Okay, now I just have to factor this. So what two numbers add up to 8 but multiply to give you 12? All right, 2 and 6. All right, so I'm going to have 4x squared. I'm going to break this middle term up using these two values, plus 2x plus 6x plus 3. All right, now I group. Out of the first group, I pull out a 2 and an x, and I'm left with 2x plus 1. Out of the second group, I'm pulling out a 3, and I'm left with 2x plus 1. All right, so I have 2x plus 1 in common. I factor that out, and I'm left with 2x plus 3. All right, set this equal to 0, and I find my remaining roots. 2x plus 1 equals 0. 2x plus 3 equals 0. So I have 2x minus or equals 1. Divide by 2. X is equal to a half. And then I subtract 3. 2x is equal to negative 3. Divide by 2. X is equal to negative 3 over 2. All right, there are my two other roots. Done. All right, here I have to simplify this radical. So I'm going to have the cube root of 25 over the cube root of 4. Okay, so 4 breaks down into 2 times 2. In order to simplify this radical, I need 3 2's. All right, so what do you do here? To rationalize the denominator, I'm going to have to multiply by the cube root of 2. All right, let's understand why I just did that. I'm going to end up with the cube root of 50 on top, and on the bottom, I'm going to end up with 4 times 2, the cube root of 8. All right, I intentionally did this because now I have 1, 2, 3 2's. All right, cube root of 8, 2 times 2 times 2. So I have a group of 3. That means I could get rid of the radical. So I have cube root of 50 over 2. Done. I've simplified the radical.